Let's continue the topic more about functions. There are functions with some special properties, and we have given some special names for them. In this session, you will learn something about even functions and odd functions. Before I tell you the definitions, maybe we look at the graph first, okay? And we start with even function first, okay? Now you can see there's a x-axis and y-axis, and then I'm going to draw a graph for an even function, but I will just draw part of it, okay? Say the graph looks like that, okay? And you can see that I just draw the graph for only positive x. But if I want to complete the graph for all real values of x, what we can do for an even function, we can say take this one, let me duplicate it, okay, and then what we can do is just do some flipping. Oh, sorry. Let me do it again. We have the graph like that, okay, and then we just like duplicate it, right? And then we take this one, just take this one, and then we do some flipping, okay, you can see that, and like this, okay, more precisely, okay. This is an even function. It means for an even function, if you look at the graph, they are always symmetric about y-axis, okay. And then what does that mean algebraically? Now it means, for example, if I take this point, the values of x here, for example, if it is 5. Now if the graph is symmetric, then it means the opposites of 5, the opposite 5, it means it is -5. And then if you trace to the graph, this is the point on the graph, and then if we trace from here, this is the corresponding point on the graph where x equals -5. These two, sorry, when we draw these two together, it should be a horizontal line, okay? It means these 2 points are having same y coordinates, okay? And therefore, in this case, if this graph is y equals fx, it means when we input the x values to these functions, and then we can get the corresponding y values. And therefore, in this case, when x equals 5, when we calculate the y coordinates, it's always the same as the case when x equals -5. And if it is an even function, this is always true for all real values of x. It means not just 5 and -5. If you take the other point, for example here, okay, maybe this one is 1.5, okay, the opposite will be -1.5. And then if you trace back here, okay, these two points should have the same y coordinates. And therefore, generally, okay, if we want to see whether the function is an even function, we check whether f of minus x is always equal to fx. We check this one, okay. Now I can give you some more examples on that. For example, if there's a function y equals x square, okay, the simple one, okay, fx is x square, but if I have f of minus x, it means I replace x by minus x, therefore we have square root of minus x, but it turns out the same as x squared. Therefore, these two are the same. Then it means this function, if an even function. If you still remember the graph of y equals x squared, do you remember that? Y equals x squared is the simple quadratic function. It looks like a parabola, and then the vertex will be here at 0, 0, and then the graph is symmetric above y-axis. Okay, therefore y equals x squared is an even function, and then you can just check the function whether it is even or not by checking this part. After looking the graph of an even function, now we have odd function. Now for odd function, okay, let's have a graph first. I just do the same. I have a graph. This one. Okay, just for also positive x only. And then now I'm going to complete the graph for all values of x. Okay, and then what I'm going to do is more or less the same. Let me duplicate this part first. Okay, it looks like that. And then just now we have done a flipping, right? We have done the flipping once to the left, okay? And then this time I'm going to do the same to the left, and then one more flip downwards. Okay, and then we move here. And then this is the odd function. Okay, maybe this one is not clear enough. Maybe I show you one more example in this case. Right, let's draw another graph. Now, this time I show you what we actually do when we really draw the graph, because we are not using the computer. When we sketch the graph, we cannot take out the graph, duplicate it, something like that. That's why if we are given an odd function, and then usually we just do the say we just draw the part for the positive x. And then in this case, in order to complete the graph, we have to do two flipping actually. We flip it to the left and then we flip downwards. And therefore, in this case, we will have to do something like that. Maybe it's not good enough. Maybe we do it much better. Sorry. Like that. Okay, this one is temporary. Of course, you can refine it like that. Okay, and then we complete the graph by imagine that you have to reflect this one about the x-axis. Therefore, you have a graph like that. If you are having the examination, that part can be done in dotted lines. Okay, otherwise you can just use a pencil to do it and then just erase it afterwards. And then we compose the graph for an odd function like that. Now, and therefore in this case, what happens if you are thinking about the reflection? Now, therefore in this case, if I take this point, if this point is okay, 5 again, and then we trace back here. Now, then imagine just now we do a reflection to the left, and therefore if we reflect this 5 to the left, therefore we are looking at the point when x is minus 5. Now, imagine if you reflect here, this point should come to here, okay? And then we do the reflection again, but this time we do downwards. Okay, therefore this point becomes here. Now, when we do the reflections, if this is y, okay, the height of this one, the point from the x-axis is y, and after we have done the reflection to the left, this one is also y, and of course this one, the length here should be y, but in this case, if this is y here, and this point come to the lower part of the x-axis, in order to show that it is below below x-axis, the length is y, but we label this number as minus y, and therefore in this case, when it means f5 if is the is the y coordinate, okay, is the y coordinate, okay, when x equals 5, and then if I look at negative 5, okay, the y coordinates are quite similar, okay, if we just talk about the magnitude or just like the distance from the x-axis, but one is above and then one is below. Therefore, the difference is the sign. Okay, therefore it means if this point is 5, 6, and then this point is having 5 minus 6. Okay, this is odd function. Now, let me show you typical odd function. Okay, y equals x to the power 3. Now, if x is 1, okay, y is 1 to the power 3, which is 1. But if I look at when x equals minus 1, then y equals the cube of minus 1, which is minus 1. Okay, one more example. If x is 2, y is 2 to the power 3, which is 8. But if we look at x equals minus 2, y equals the cube of minus 2, then it becomes minus 8. Therefore, when you are asked to check whether the function is an odd function or not, we check whether f of minus x equals negative of fx. Okay, then we can look at the examples on the next slide.